Hello everyone, this is a tutorial video for regional analysis core in which I am going to introduce you to the regression analysis but the theoretical part of the linear regression analysis um, are in three different video. Not mine video, but an available YouTube video in which the theoretical part and theoretical background of the linear regression analysis are well discussed and easily to understand the mathematical background of the regression analysis. So I was linked. I have added for the co-space task the free video. So first of all, watch these videos, and after that watch mine videos. Here we are going to use familiar datasets with NUTS 2 regions, the data of NUTS 2 regions in Visegrad 4 countries: Czech Republic, Hungary, Poland, and Slovakia, and area, population, unemployed people, and GDP as well. And we just make calculations, and we are going to calculate the R-square values for the population density, between the population density and the GDP per capita as well, and for the unemployment rate, between the unemployment rate and the GDP per capita. And here we are. This is all of the relative variable is all of the relative variables are calculated, and after that we can calculate the R-square number. For first of all, we can calculate for 2 of population density, and similar to the correlation coefficients, insert chart and scatter plot. And here we go again. There is an outlier, Czech Republic, Prague, so just grab and exclude the outlier, and after that right click to the point and add trend line, and click on the display equitation on chart and display R-squared value on chart. And here we are. We have the equitation, which is described in the tutorial video, the first three tutorial video. This is B1 and this is B0 in the tutorial video, and this is R-square number, which is automatically calculated in the scatter plot in Excel. So we can just make a calculation in the Excel, just 1 or 2 clicks. Population density 2006 and 2015. Yeah. So there is a very huge relationship and dependency determinantship between the before population density. So the spatial structure of the population density has a very huge past dependency. Okay, but the others, for example, unemployment rate. Yeah. Just select the two variables for the unemployment rate and insert chart. Okay, we have higher standard deviation. Okay, click on the points and add trend line. Yeah, linear is a very important things, and display equitation and display R squared as well. We have the B0 and we have the B1 value as well, and the R square value, which means that the spatial structure of the unemployment rate is more changeable than the population density. So we have a lower number for the regression coefficient. But add a title: unemployment rate 6 and 15. Okay. Okay. And after that, we can also compare different kind of variables. For example, the population density and the GDP per capita. But there will be two outliers. Yeah. So we have to copy these two. Yeah. Okay, and delete the two outliers, Bratislava and Prague. Okay, and insert chart, scatter, dot, and we can add trend line, linear trend line, and display equitation on a chart. There is a low and weak relationship between the population density and GDP per capita. R square is 0.2. Nation between pop density and GDP per capita. Okay, we have the diagram and the R square too, and we can make such a calculation for the GDP per capita and unemployment rate as well. Okay, but we should delete the outliers. The trend line, and the R square, and the equitation. And in this case we have 0, a negative B0, so we have a negative relationship between the unemployment rate between the okay. Okay, so for today, this was the task. Just make a calculation, make a regression calculation, and try to understand the mathematical background, which is in the three other video. So thank you for your attention, and see you next week.